Okay, so now that you've named polyatomic ions, hopefully you're getting used to that naming system, we really have two other minor naming systems left. One of the minor naming systems that we have is naming acids. Now, acids are a particular group of elements that have their own physical and chemical properties, and they just kind of have their own little naming system. So that's what we're going to talk about now. Now, just to give you an idea, though, of what an acid is, okay? An acid is a substance that contains the element hydrogen, okay? And what it's going to do is it's going to eventually donate that hydrogen to another substance, okay? Well, that's kind of nice if an acid is pretty much anything that contains hydrogen. Hopefully you can realize what group of elements that would probably like to bond with, okay? So, and hopefully you're saying that that group is probably, say a group 17 element, like a halogen. And so the first type of acids that we're going to talk about are actually called binary acids. And there's that word binary again, and meaning two. And what this is going to mean is this hydrogen is actually just bonded to another atom, in particular an anion, which just so happens to be a group 17 element. Now, it's not the only element it has to be. It's just typically a group 17. So here are a bunch of binary acids. And actually, those are the main binary acids. And you see right here, I have fluorine, chlorine, bromine, iodine. Okay, those are the group 17 elements that hydrogen mainly bonds with. And then here's a group 16 element that it also bonds with. But those are all our binary acids, and to be perfectly honest, those are the main binary acids. Now, with this naming, okay, all binary acids are named the same basic way. Okay, and I'm going to give you the rules first, and then we'll go through and look at the examples. The first rule is we're going to use a prefix hydro. Okay? And you probably recognize some acid names, and you probably heard of hydrochloric acid. Okay? Well, we use that prefix hydro for these. And then you use the root word of the anion. Okay? So if the anion is something like fluorine, okay, we'll use the root word of that, and then what we're going to do is we're going to add a suffix to that, an IC ending. And then we'll always add the word acid at the end of it, so we know that we're talking about a specific acid. So what we're going to be doing is we will use the prefix hydro. We're going to put a root word in there, and then we're going to put an ic on the end of it. So it's going to be a hydro something ic. Okay? Now, going back up here then, here's my first binary acid. Okay? It's fluorine with that hydrogen. So we're going to put hydro and then fluorine, but we're going to put ic on it, and it's going to be hydrofluoric acid, and that's how we would name HF. HCl, hopefully that looks familiar to you. Okay? It's got chlorine in it, so we're going to use the root word chlorine, and we're going to put ic on the end of it, so it's going to be chloric, but we're going to put the prefix hydro in front of it, and so it's hydrochloric acid. HBr, bromine, hydrobromic acid. HI, what do you think? Oops. Hydroiodic acid. Okay, and this last one, H2S, is a little tricky, but it's actually called hydrosulfuric acid. And that sulfuric is going to be a little bit of a pain later on. But that's how we name binary acids. And to be perfectly honest, these are the key binary acids that we really need to worry about. Okay? Other ones are just some minor ones. Now, there's a few issues that come up with naming binary acids. because in previous worksheets you've actually had HCl and you've called it hydrogen chloride, which is perfectly legal. Hydrochloric acid basically has two names. It can go by hydrogen chloride or it can go by hydrochloric acid. Okay, same with HBr. It can be hydrogen bromide or it can be hydrobromic acid. Okay, and I have a little quick test here then. So naming wise, okay, take these two compounds and see if you can name them. Okay, we're going to use the prefix hydro. We're going to use the root word and we're going to put an ic on the end of it. Okay, so hopefully you realize that Te is terrellium. Okay, that's what Te is. So this is going to be hydrotelluric acid. Okay, and how about the Se? Se is selenium. So if I'm going to name this, it would be hydroselenic acid. Okay, and one thing I probably didn't point out real well, the hydroselenic, hydroterrelic, those are all one word. Okay, going back up here, I'm going to have to move this down for a second. Okay, these are all one word. There's hydrofluoric is one word. There's no space in between it. Okay, and basically, right there, I have actually listed every single binary acid we have. There are no other binary acids than the ones we have right here. Okay, another type of acid that we have, however, which there's a lot more of, is called an oxyacid. Now, hopefully, just in that name, you see oxy. And learning chemistry as we go here, you're probably going to realize that that has oxygen in it. So an oxyacid is an acid that contains hydrogen, oxygen, and one other element. Now, one of the nice things to learn, or one of the things to learn right now, is that recognizing that you have a polyatomic ion is actually the key, because basically an acid is hydrogen attached to a polyatomic ion. So that big polyatomic ion list that you have, if you put hydrogen in front of any one of those, you now have an acid. Okay? So that's kind of what we're looking at here. So right here, one of the things to look at here and recognize is that you have a polyatomic ion. Okay, that polyatomic ion is ClO2. And now you go to your polyatomic ion sheet, okay, and you look up what ClO2 is as far as a name. Okay, and one of the things you realize is that its name is chlorite. Okay, now I need to name this acid. And what happens is, whenever you have a polyatomic ion that has an ITE ending, what you're going to do is you're going to change that ending to an OUS ending. Okay, so all of your ITEs change to an OUS. So to name this acid, this becomes chlorous acid. So we just got rid of the ITE and put an OUS. And we got chlorous acid out of it. Okay? To give you another example, if I have HNO2, NO2 is nitrite. Well, that nitrite has my ITE ending, so I'm going to change that to an OUS, and that becomes nitrous acid. So all polyatomic ions with ITE will change to OUS endings. Okay? Now, you have the polyatomic ion HClO3. ClO3 has a different ending. ClO3 is chlorate. Okay, and you'll notice that this is not chlorite, so I'm going to have to come up with another naming system. So when you see ATE as an ending, what you're going to do is you're going to add an ic to it. Okay, so ates are going to become ics. So this is going to become chloric acid. Okay, so the chlorate here, we put an ic. Okay, so what happens here is ITE endings of polyatomic ions become OUS, and ATE endings of polyatomic ions become IC when you are naming acids. So this is when a hydrogen is involved. Okay, so it's when you have a hydrogen involved in this. And there's a silly little saying out there, okay, to kind of help you remember this. I ate something icky. So ates become icky. I don't know. Someone came up with that a while ago. I thought it was kind of cute, so I thought I'd share it with you. Okay, so essentially what we need to do is kind of practice this. So take out your polyatomic ion sheet, and we're going to go through a bunch of different examples. Okay? So let's look at H2SO4. Okay, this is an acid, and what I want to do is I want to find the name of SO4. Okay, and hopefully by now, okay, after doing a large number of those polyatomic ions, you're starting to become familiar with the fact that that's sulfate. Okay, that sulfate is my ATE ending. That's going to become an ic. So the name of this acid is sulfuric acid. Okay, and you'll notice that we added an O, a UR in it. So it's not sulfic acid, it's sulfuric acid. It just makes the name sound better. Okay, here's another one, H3PO4. PO4 is phosphate. There's the 8. That 8 is going to become an ic. And to help it just flow better, this is called phosphoric acid. And again, we added a little bit to the name. We went back to kind of its original name, but we put an IC on it. Okay, notice on all of these, none of these we put a hydro in front of. Okay, the hydro prefix does not belong here because that is only for binary acids. Okay, so it's just phosphoric acid. Let's give another one here. See, we did sulfuric, phosphoric. See if you can name that acid. This polyatomic ion is nitrate. That's going to become an ic, so this is nitric acid. Okay? Now, we can't forget about the OUSs. So I have H2SO3 is also an acid. This SO3 is sulfite. I almost forgot what it was. Okay, well, now I'm back to that ITE ending, And remember, ITE endings become OUS. So this is sulfurous acid. Okay? And this pretty much is the naming system of acids. So okay, I'm going to look at group 1 ions, and I'm just going to give you a formula, some various formulas here. So I have HCrO2. So go find that on your polyatomic ion chart and name it. And what you should find is the CrO2 is called chromite. Ite becomes us. So this is chromous acid. That particular compound is chromous acid. Okay, if I give you HOCN, OCN is called cyanate. Well, there's that ATE ending, which becomes an ic. So this would be cyanic acid. Okay? So basically what you're looking at here is you're looking at polyatomic ions. Okay? And it's basically a hydrogen ion with a polyatomic. And that's what gives you an acid. Okay, I should be specific. That's what gives you an oxyacid. Okay? And the polyatomic ions that end in ATE, that changes to an ic ending. And if it's a polyatomic ion with an ITE, that changes to an OUS ending. Right? And that's essentially what naming acids is. Okay? You have a worksheet now that you can go through and practice naming acids.